face cards. And we talked about this on Friday. Face cards are going to be Jack, Queens, and Kings. Gentlemen. Jack, Kings, and Queens are your face cards, and there are four face cards per style, one for each suit. Suits, if you recall, are diamonds, hearts, spades, and I want to say clover again, clubs. So you wind up with 12 of them. There are 12 face cards, and you want 5 of them. So in a standard deck of cards at the 52, there are 12 face cards, and you want 5 of them. How many different ways can you be dealt that? When you do the math on it, it seems like it's a big number, but then remember, that's out of the 2.6 million total possible hands of cards. Okay? It's not 2. It's like 2.259 or something like that, so we just roughly 2.6. 4 aces and another card. Well, how many aces are in a deck of cards? 4. How many of those do you want? 4. So there are 4 aces, you want all 4 of them. How many ways can you get all 4 aces if there's 4 of them? 1, because there's only one way you can get all 4 aces. You get all 4 aces. That's kind of what that means, okay? And then how many other cards are there that aren't the aces then? 48 of them, and how many of those would you get? 1. That's why your answer for that one was 48. Okay. 1 ace and then 4 other cards that aren't aces. So how many aces are there? How many do you want? 1. Which means there are 48 other cards that aren't aces. How many of those do you want? And that's what that would look like. For those of you guys that were gone, it doesn't sound so scary, does it? Oh. 2 aces and 3 kings. Remember what that's called? Full house. Now, if I say it's a full house, it means you've got 3 and 2, but the technical way to say it is that it's a full house with kings over aces. You say the one that you have 3 of is over the one you have 2 of. So if I have a full house, jacks over 3s, 3 jacks, 2 3s. If I say I have full house, 2s over queens, 3 2s and 2 queens, and so on. That's not too bad. 4 aces and 3 kings. Excuse me. How many aces are there? 4 of them. How many do you want?
2.
How many kings are there? How many do you want?
3.
And that's the different possible hands that you could get. Not very many of them. Okay. Only 24 possible hands out of the 2.6. Yes, sir.
So now, forgive me because I've been gone for class for 2 days. So in this case, when we're putting these in here, we don't need to put them through the equation to get like a full number.
We are. There's a button on the calculator that does the choose. It's alpha window 8. And if you type it in, if you look at your calculator, I know that, let's say I'm going to do 4C1, 48C4. What I would do is just do 4 alpha window 8, comes with the C, 1, hit the right arrow, times 48 alpha window 8, 1.
So if we use P and if we use C.
Oh, I meant to use a 4 there, excuse me. Permutation is when order matters. Combination is when it doesn't. Permutation is think about race. When you're in a race, there's only first place can't be fourth place.
Yeah.
Deck of cards, I'm dealing you 5 cards. Does it matter what order those cards get dealt to you? No, not at all. And that's where this stuff comes into play. It's actually pretty quick to start once you start doing more of these. And there's a couple today that in the homework that have a mixture of you'll have to make a decision: is it permutation or is it a combination? And as you read it, you'll start to think: does the order in which I select this have a matter to it? And as you get going, you're like, oh, it's really not that bad. Okay. So it's not 192. This should have been a 4 there, but it's just a button. We okay with that? Okay. 4 of one kind, kings, queens, and so on. This was the goofy of all the problems that are around there. I think some of us we talked about this in class. How many different kinds are there in a deck of cards? 13. What that means by kind is ace, king, queen, jack, all the way on down to 2. There are 13 different face value cards. 4 of one kind, which means first thing you have to do is pick a kind. So there's 13, choose a kind. Of that kind, how many cards do you want? 4. You want all 4 of that kind. So if I pick a 3, in a deck of cards there are 4 3s. So I chose that I want to try and get all 4 3s. So I picked my 3. 13 pick 1. That gives me my 3. Of that kind of the 3s, there are 4 of them. So there's 4 possible. I want all 4, so it's 14. Choose 4. And then that leaves you, well, excuse me, what's left over? How many cards are left over? 48. And how many of those do I want? 1. And I think some of you guys, or somebody in here, just wrote 13-1 and then 14-1, or 48-1 if I'm not mistaken, correct? Because what's 4 choose 4? The reason, excuse me, I'm choking. The reason I put that 4 in there is because it's telling me that I wanted to go. That's all. Because later on we're going to do what are the possibles for a full house. Pick a kind, choose 3 of them. Pick another kind, choose 2 of them. You know what I mean? That's why I'm introducing that. So I know a lot of you guys were out. That's really what we're looking at here, just combinations. How many different combinations of stuff did you get? Then after that, we walked around and tried to guess cards, and nobody in here won. So you guys are all losers.
Then what are you?
The ringleader of the loser movie.
You taught us.
I didn't teach you how to guess.
Gotcha.
What are you whining about?
I'm not whining about anything. I'm just saying.
What facts are you stating?
They were valid facts, but not.
Please don't.
So here's what we get into. We have to get, when we do combinations, there's a decision that you have to make.
Just go back up.
This is still 12-2. Yeah, this is the last half of 12-2. What we did on Friday, because I knew that a lot of people were gone, was just kind of talk about cards, and we just kind of took our time doing that, not trying to get through. Usually what I do with 12-2 is I do all of this stuff all in one day, the cards and the multiply and add portion, but knowing that we had so many people out, we just cut it out. Then tomorrow what we're going to do is, because I won't be getting all of it in today, tomorrow we'll talk about Pascal's triangle and what's called binomial expansion. There's a shortcut. Yes. There's a shortcut for doing really weird binomial expansion problems. And that'll help us with, believe it or not, when we get into what's called normal distribution, which is just binomial distribution on a grander scale. Anyway, deciding whether or not to multiply or add. Well, when we're dealing with combinations, you have a choice. And it really whether to do one or the other, it depends on a specific word. Multiply versus adding when we're talking about combinations. This is really, really difficult. Just kind of being silly. What happens in these problems is you're going to see the word and you're going to see the word or. Oh, did I?
Yeah, that's why
I was wondering why you guys are looking at me like, what are you doing? Now does that help?
That's a little less.
It's what happens when you spell things wrong. You can either go to the desert or have dessert. I don't know. That's the only way you remember it.
That's all right.
Drew's trying to figure that out. Would you rather have more desert or more dessert? It depends if you get to leave in the desert. So you go to this fancy schmancy restaurant to get an omelet. Okay? And these fancy schmancy omelets are $3. For each ingredient, it's an extra 50 cents.
Wow.
Okay? I know it's a lot here. So you're going there, and you only have now. This is just no tax, no tip, no nothing. It's just tax and tip are included. Yes. This is a European place, and you have $4.50 on you, which means you're going to have exactly. Right. But you want two, because your mom told you to eat healthy. So you're going to have 2 vegetables and then a meat. So here's what happens. You're going to choose 2 of the vegetarian. There are 6 of them. Does it matter if you choose onions before cheese or mushrooms before green peppers? No. You order which they do because you're still just going to mix them all together anyway. So there are 6. You're going to choose 2 of them. Now this crazy word right here, and means I'm going to do what between them? Multiply. These are very similar to what you did with the cards. You wanted an ace and a queen. Things like that. Okay. How many meat toppings are there?
4.
How many of those do you want? So, because you are nothing but the smartest person at the restaurant, probably not, but you brought your calculator and you wanted to show off because that's what you do. You put that in the calculator and say, well, for my $4.50, I could have 60 different omelets. I can choose between 60 different omelets.
And that'll get you nowhere, it'll just make you more indecisive.
I agree.
You can make 60 different choices.
I agree. So, next time you guys are pulling your money together to buy a pizza, think about the toppings and how much money you have. You can take this and say, hey, bozos, don't go off with just, hey, I'm ordering sausage and pepperoni. We can choose from a bunch of different things. And then they'll throw something at you and kick you out. Yes, ma'am? Yep. Correct. And then for the addition one, it's going to be or. Because let me show you what happens when you talk about or. Suppose you can afford at most 3 ingredients. Once again, you only have $4.50. And you're taking into consideration you're not going to listen to your mom and eat healthy, which means you can have 3 different meats on your omelet, or you can have 3 different vegetables, or a combination of any of them. Which means the word at most. Could I have more than 3? Could I have 3? Could I have fewer than 3? So that means out of these 6, I could have 6 of them choose 3, or 6 of them choose 2, or 6 of them choose 1, or 6 of them choose nothing and just have eggs.
Yeah.
Okay?
I like that you have to go into the meats too, or no?
What's that? Oh, thank you. There are 10. I was stuck on vegetarian. Yeah, these should be 10s. I'm sorry. Guys, the reason that those are 10s because there's 10 total ingredients. I was just stuck back in my mind about thinking about vegetarian stuff because I was listening to my mom. Eat healthy. So what happens here is you just press the buttons in the calculator a couple of times. Okay? You just press the buttons a few times and the calculator will be able to do that. And yes, an omelet is still an omelet if you put nothing on it. It's just fried eggs flipped over. They're non-chopped up scrambled eggs. Think about it. How many? There are 176 options then for doing that. No, seriously. Some people like fried eggs. I like fried eggs. But if you think of it as instead of being a yolked fried egg, this is a scrambled fried egg that's not chopped up. You know, it's scrambled. It's all mixed together, but it's just in one big egg pancake. And it's an eggerito. Yes, sir.
So this basically means you have 176 ways you can arrange it.
Correct. That's exactly what that means. All right. Yes, ma'am.
Do you think we could do like 3 factorial instead of like in the equations instead of adding all this?
It doesn't work that way because if it's 3 factorial, that's 3, 2, 1, which is 6. That's 2, 1, which is 2. This is 1, 1, which is 1. And this is 0, which is 1. Okay. And it doesn't get you there. The whole idea of the combinations is you're thinking of there are 3 choices, I'm going to choose all 3 of them. There are 6, I'm going to choose all, there's 2 of them, I can choose all 2 of them, and so on and so on. So this is, I'm going to take all the toppings, 2 of the toppings, 1 of the toppings, and the different ways of going through it. It's a different setup, okay? So it's not exactly the same. And a lot of this stuff is very similar, and I will do my best to make sure it's worded so it doesn't get that ambiguity that you're not exactly sure what's going on. Okay. Then?
Isn't this how like locker combos are like misleading because they're actually not combinations?
Correct. Locker combinations aren't combinations, they are permutations. Did you guys know that? Your locker combination has to be done in a specific order, so it's a locker permutation, but it sounds cooler to call it combination.
I feel like it only sounds fun because that's just what we call it. Because locker permutation.
Yeah, because if we called it a permutation, then we'd be like, wow, that'd be weird to call it a combination.
Okay, well, again, you guys are smarter than me, so whatever. Hey, second hour didn't believe me that this is really a thing, that you buy season tickets to a theater.
Yes, you can. Yeah.
Yep.
Yeah, I work on wrong.
My in-laws do. They go to the Lincolnshire Marriott, conveniently in Lincolnshire. I know. And they have a theater out there, and every couple of months or so there's another play and things. And each year they buy it, and they buy X amount of plays without knowing which they're going to wind up being. So what they're doing is, in a theater that has 12 possible plays, you want to attend at least 3 of them. So even though you're buying season tickets, you want to go at least 3 of them. How many different combinations of the plays can you go to? I know it sounds like a really weird problem, but this is kind of the same idea of when people buy season tickets to sporting events. They know that there's a certain amount that they want to go to, and then they want to sell other ones to make their money back. Kind of the same way it's the law of diminishing returns, of where do you break even and things like that. This is a whole economic side to this style of a math problem. We don't touch it here, but it is something they talk about in stats, just so you know. Yes, ma'am?
I just don't understand like what do you if this were like in real life and you bought these season tickets and you're like, I want to go to at least 3, why would you say like, oh, let's do these combinations? Because would it depend on like the day you wanted to?
Yes.
So what I'm hearing.
You're right, and that's kind of where this stuff gets to. Probably dumb. So here's what happens. When you start to think about it, if you have 12 of them, you want to go to at least 3. If you go to at least 3 of them, could you go to 3? Can you go to more than 3?
Yes.
Can you go to less than 3? No. So you have 12 of them, choose 3. 12 of them, choose 4. 12 of them, choose 5. Now, there's 2 different ways of going about doing this. One of the ways is to just write it out a bunch of times and press buttons on the calculator. That's fine and dandy. But what I want you to remember is that back in the day, we didn't have these fancy things called buttons on calculators with N, choose, R, and stuff like that. We had to do it on rock, not paper, nor with scissors, but we had to use rocks. There were no scissors. So, let me ask you this. What's the probability of rolling a 3 on a regular 6-sided die? 1 out of 6. What's the probability of not rolling a 3? These two are called complements of one another. Okay? Thank you. So, 1 minus the probability of the event occurring is the event not occurring. Or 1 minus the event not occurring is the event occurring. It's easy for me to show you guys that in terms of a probability statement, even though we haven't technically talked about probability, because you understand the concept of rolling a 3 or not rolling a 3. I'm hoping, right? I hope so. Good chance?
Not really, actually. It's not.
Yes, ma'am.
So it's like, if you were doing like 27 minus 25, it's easier to just like add 2 to get to 27 than it is to.
And that's the idea. What you have to figure out is, what is that 1 for this? Well, the 1 for this is the decision to go or not to go 12 times. If you decide to go, if you're going to go to a play, there's only 2 things that can happen. You go or you don't go. How many times do you have to make that decision? 12. So the go, no go would be 2 to the 12th power, because you're saying yes or no 12, basically 12 times, and that's compounding itself through. To that, you would just subtract, well, what's left here? 12 choose none, 12 choose 1, and 12 choose 2. When we didn't have the calculators with the buttons, we utilized the idea of subtracting out the leftover from like the decision of go, no go type idea, because it was a little bit easier. Because remember, combination formula, was the NCR was N. When we had to do this out longhand, it wasn't hard, but only had to do it 3 times as opposed to 9 times. It's just easier. That's all. That's
Is that just what is this then? Either subtract 2 or
these two will work out to being the same, because this is your total decisions. That 2 to the 12th power is your total decisions, go, no go. And this is the ones that don't fall into at least 3. It's the 2, 1, and not going at all. It's buying season tickets and saying, this for a write-off, this donation, charitable donation or something like that. Still, wouldn't want to go. Maybe you couldn't find a sitter 12 times. It's possible.
Your kids are just that bad that no one wants to watch them.
Yeah.
That's what like.
I hope my children aren't that bad where no one would want to watch them.
How do you feel sad?
I know. I feel pretty bad about that.
My ancestors are so bad that who's like, I think he's like 7 now. He got from like regular public school, he got sent to a school specifically for like kids with like anger management, and he managed to get kicked out like literally one day.
Nice.
That's
That's talent. Questions?
No.
This is why I didn't want to get too much into this. I probably could have done all of that on Friday and said, the heck with the rest of you bozos ditching school. Ooh.
We were AP.
I know.
Oh, no.
Yeah, in fact, we were in school longer than everyone else.
Yeah. 14.
Okay. Math.
Thursday's gonna miss you.
Wait, can we add this to our?
Yeah, that's fine. Yeah, just add those to those 5 from the other day, and we'll go from there. There was no fire alarm today.
those supposed to be
Well, now they'll be an intruder because somebody just left.
Looking back on it, I would rather would have
Doesn't
had
matter.
the